What's up? Welcome to Models and Agents, episode 52 for May 18th, 2026. New week in AI, and if last week was anything to go by, buckle up. Let's get into it. NVIDIA's 4-bit pre-training technique cuts memory needs for large hybrid models while keeping accuracy nearly identical to FP8. The core development is a full 4-bit pre-training stack called NVFP4. It was validated on a 12 billion parameter Mamba-Transformer hybrid trained for 10 trillion tokens. The method combines selective BF16 layers for critical weights, 16 by 16 random Hadamard transforms on gradients, two-dimensional weight scaling, and stochastic rounding. Downstream accuracy stayed within 0.04 points of the FP8 baseline. That is 62.58% versus 62.62% on MMLU-Pro. Teams running extended pre-training on constrained GPU fleets now have a documented path to reduce memory and interconnect pressure. Watch for follow-up work on larger dense models and whether the same recipe transfers to pure transformer architectures. Community forecasts point to new open-weight model drops likely landing between late May and early June. Posters on r/local LLAMA note a shift in how open-weight submissions are being handled. They are watching for signs that major labs are extending the current cadence. Tests on Chwen 3.535, BA3B, and its no refusal fine-tune show register-dependent expert routing even before refusal layers activate. AAVE-coded safety prompts produce different first token routing tensors and longer thinking traces than matched academic English prompts. This raises questions about whether refusal alone masks underlying safety gaps. Loose DFlash plus PFlash delivered 2.24 times decode and 3.05 times prefill speedups versus llama.cpp HIP on an RX 7900 XTX. The optimal DD tree budget was 8 rather than the 22 recommended for Strix Halo. This highlights how GDDR6 bandwidth changes the best speculation strategy. A new agent built specifically for 4B to 14B local models reaches 87% on coding benchmarks. It replaces chain tool calls with compound actions, automatic lint and fix loops, and on-demand escalation to larger models. Small code runs against LM Studio or Alama endpoints and keeps 95% of work local. Developers are exploring dedicated local models that read a testing.md or quality.md file. These models continuously refactor generated code for security, readability, and maintainability, without sending large code bases to cloud APIs. Simon Willison argues that useful AI-generated tools save reviewers time, while unedited LLM slop wastes it. He recommends including detailed terminal sessions that demonstrate exactly what was tried and how success was verified. Any LLM output containing opinions or anecdotes must be closely directed and reviewed by a human. Willison calls out examples where models falsely claim months of personal usage as particularly harmful. Karpathy noted that simply saying boot in 8 times H100 in a tutorial immediately blocks most viewers at step 1. This highlights the gap between assumed hardware access and real-world availability. Okay, let's pop the hood on data mixing. Everyone talks about data mixing as a one-time hyperparameter you set at the start of training. In practice, it is a recurring online decision that must be solved at every phase of the model lifecycle. The core insight is that you can cheaply simulate candidate mixtures by interpolating between low-rank adapters already trained on the current checkpoint. This avoids training separate proxy models from scratch. The approach keeps the search grounded in the model's actual learning dynamics rather than an earlier snapshot. It adds negligible overhead per decision, yet finds mixtures that improve average perplexity by roughly 6% over static baselines during pre-training. In continual learning, it matches full retraining or distillation performance while using 66 to 95% less compute. The practical takeaway is to treat mixing as a lightweight inner loop that runs every few hundred steps rather than a single upfront choice. The main gotcha is forgetting to reevaluate when the data distribution or training objective shifts. Test the loose D-Flash plus P-Flash setup on your AMD card with Chuan 3.627B. See whether budget equals 8 gives you the reported 2.24 times speedup on short generations. Run small code against a local 4B to 7B model on a real code base. Compare failure rates to your current agent workflow. Add a short terminal session block to your next project README to show exactly how you verified functionality. Follow Simon Willison's recommendation on that one. Experiment with OPMIX style low-rank adapter interpolation on your next continued pre-training run. This keeps data mixing decisions current without extra proxy models. Community forecasts point to new open weight model drops likely landing between late May and early June. Further scaling experiments on the NVFP 4.4-bit pre-training recipe are expected once labs move beyond the 12B hybrid proof of concept. More work on dialect-aware safety testing for MoE models is likely after the recent routing divergence findings. Tomorrow, keep an eye on the first public follow-ups to the NVFP 4.4-bit pre-training runs, as labs test larger, dense models. That wraps up today's AI briefing. Share this with a developer or builder who wants to stay current. Subscribe wherever you listen. See you tomorrow. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.